Yeah, good evening, one and all. Can you please respond whether my voice is audible? Welcome to VCube Software Solutions for the 15-day internship program on AIML. Yeah, thank you very much. Let me share my screen. Yeah, can you respond whether my screen is okay for all of you? Yeah, thank you. Yeah, welcome to the today's session. Yeah, before going to the today's session, I will be discussing about what I have discussed yesterday. Yesterday, we discussed about regression analysis. Okay. Then we discussed about various use cases of regression analysis using simple linear regression, multiple linear regression, and lasso and ridge regressions. Okay. Today, the topic is on classification algorithms and its use cases. Clear, guys? Shall we go ahead, please? Yeah. Now, today I will be starting the concept of what is classification. Okay. Before going to that, first of all, I will discuss what we have discussed yesterday. First, we discuss the machine learning has been divided into first one is supervised learning, second one is unsupervised learning, and third one is reinforcement learning. Okay. Now, supervised learning once again divided into first one is regression analysis. This is yesterday topic, and today's topic is classification. Okay. This is our today's topic. Now, when can I take classification technique? So everyone knows the supervised learning means we have input data has to be mapped with target variable. X is called as input data and Y is called as output data. Here we are going to use algorithm f of x. Today's this f of x is nothing but classification. Now, when the target variable Y is either categorical data or you can also call it as qualitative data. Okay. Then we are going to apply a technique called classification. I hope everyone is okay. Once the target variable is either categorical or qualitative, then we will be discussing the technique called classification, which is our topic of today. So can I go forward, Amma? Yeah. Now, let me start. What is the meaning of classification? Okay, what is the definition of classification for a few minutes? Classification is a predictive modeling problem where we are assigning a class label for unknown tuple. That means we are going to assign a class label for unknown tuple. Now, classification can be categorized into three different classification. First one is binary classification, where we have two class labels. Okay, where we have two class labels. Second one is multi-class classification, multi-class classification, where we have more than two class labels for target variable. Okay. Third one is multi-label classification. In multi-label classification, what we will do, instead of giving one label, we will be giving more than one label for target variable. So what is binary? Binary classification is the task where examples are assigned exactly one of the two classes. Okay. And in multi-class classification, what we will do, where examples are assigned exactly one of the more than two classes. That's it. Okay. In multi-class classification, you will be having more than two classes, and in binary classification, you have two classes. Out of these two classes, we will be assigning one of them. Okay. Third one is multi-label classification, where we will be assigning two labels for one target variable. But this is very rare case. Okay. In binary classification, the task with the two classes, multi-class classification, a class with more than two classes. Is it okay for all of you? Now let us take a beautiful case study called whether a patient is diabetes or not. Okay. So here diabetes is yes is one class label and no diabetes is another class label. So this is called as binary classification. Okay, for all of you. Now let us take whether an email is spam or ham. Email is spam or ham. Here we have two classes. When the target variable is ham, that is called as good mail or good message. When the target variable consisting of unwanted data, that is called as spam mail. So here we will take various kinds of mails, and our mailbox will classify whether the mail is spam mail or whether mail is ham mail. This is also binary classification. Clear for all of you? And third one, here I will be discussing about a malaria cell image dataset, where any blood cell consisting of this kind of symbols, this is called as parasitized. Now here, if you find out this blood cells does not contain any unwanted, here this is called as uninfected. This is also called as binary classification. Like this, we can have hundreds of examples for binary classification. So if you ask me an example for multi-class classification, okay? If you ask me an example for multi-class classification, let us take digits 0 to 9. Okay? Here I have 10 labels. Out of 10 labels, I will be assigning one label as target variable. This is called as multi-class classification. So with your permission, shall I go to the today's topic? Now today we will be discussing about these techniques. Okay. So classification consisting of various kinds of algorithms such as KNN, decision trees, Bayesian algorithm, support vector machine, logistic regression, and various kinds of neural networks such as ANN, CNN, and RNN. All these things comes under classification. Is it okay for all of you? Now, another very, very important slide everyone should know, because whenever I wanted to execute ML algorithms, whenever we are executing ML algorithms, we will be taking a library called scikit-learn. So every student must know about this figure. This figure will say that how to choose right regression algorithm or right classification algorithm or right clustering algorithm. Okay, this is the one of the best diagram. Okay, you have to choose. Now, if you observe carefully, we will start here. If I have more than 50 samples, observe carefully. If I have more than 50 samples, then I have to see the categorical data. When the target variable is yes, this is called as label data. When I don't have target variable, I will go in this technique. Once again, I'm repeating. Now, when the label data is yes, we'll take classification techniques such as Bayesian algorithm, SVM algorithm, KNN algorithm, gradient descent algorithm, and so on. Okay, for all of you. And kindly spend a few minutes after the class how to choose right estimator in the Google. This is the one of the most important technique. How to choose right estimator for a problem. This is a very, very important slide. So with your permission, I will be stopping my slides and I'll go for algorithms one by one. With your permission, can I go, Andy? First of all, I will start KNN algorithm. Then I will go for Bayesian algorithm. Then I'll go for decision tree algorithm. I can discuss only these three in next 1 hour. Okay, for all of you, ma? Yeah. Thank you very much. Now, let me start. What is KNN? Let me close this slide. Yeah. Now, can you please look at here? The screen is okay for all of you? Yeah. Thank you. Yeah. Let us start with the first algorithm called as KNN. Yeah. Now, if you look at this KNN algorithm, the first algorithm is called as KNN, nearest neighbors. Okay. Now, the basic fundamentals of KNN algorithm is here we will be having a data set D, okay, which consisting of two features. Height features in terms of centimeters, I will call it as X1. Weight feature in terms of kgs, I will call it as X2. And t-shirt size is a target variable Y. Okay. T-shirt size is a target variable Y. Here, medium is one label and large is another label. So shall I call this as binary classification? Shall I call this as binary classification? Can you respond to me? Okay. Because I have only two class labels out of medium and large T-shirt size. We'll call this example as binary classification. Now, I will go in detail into mathematics of KNN algorithm. Can I go forward? Yes. Now, totally I have three columns and these two columns are called as input X and T-shirt size is target variable Y. Now we need to find out the relationship between X and Y by using f of X. This f of X is nothing but KNN algorithm. Okay. Now, what is the first step in KNN algorithm? First of all, you have to calculate similarity distance. Yes. You have to use various kinds of similarity metrics. Now, in computer science, we have various kinds of similar like Euclidean distance. Mostly in your sixth standard, you studied about it. Second one is Manhattan distance. Third one is cosine similarity. Fourth one is Jacquard similarity. Like that, you have around 50 plus similarity metrics are available. Okay. KNN algorithm is a distance-based algorithm. Okay. The basics of KNN is distance-based algorithm. Either you can take Euclidean distance or Manhattan distance or cosine similarity or Jacquard similarity, or there are 50 plus similarity metrics are available. This is the first step of this algorithm. Is it okay? Then, what is the idea of this KNN algorithm? Idea is to find out the distance measure between here. The idea is to find out the similarity between new sample. Here, I will be taking a new sample called Maunika. I will call it as unknown. Who is having height 161 centimeters and weight 61 kgs. What will be the class label? Will she wear large t-shirt size or will she wear medium t-shirt size? This is my problem to be solved with KNN. I hope the problem is okay for all of you. I hope the problem is okay, Nama. Now, what is the distance between Euclidean distance? In order to calculate Euclidean distance, we will take 2 points, x1, y1 and x2, y2. Okay. How it will be calculated? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the distance metric. So what I have to do, I need to find out the distance between these 2 points. See here, 161 and 61. This is my unknown point. I need to find out the distance between unknown point to every point in the database. Okay, Nama? How to calculate? Square root of, let us take 158, 58 as x1, y1 and 161, 61 as x2, y2. So what is the formula? x2 minus x1. So 161 minus 158 whole square plus 61 minus 58 whole square. So what is the meaning of the term? Square root of 3 square plus 3 square. Okay. So it is square root of 18. So square root of 18, can I call it as 4.1 or 4.2? Can you respond, Amma? Here. Now you need to find out the distance between, unknown point to every row in the database. Similarly, we will calculate distance between all training samples with the new database and calculate the rank. How to calculate rank here? See here. Now the smallest distance will be given rank 1. See here, Amma? See, please see here. Now we have calculated the distance between unknown variable to each and every row. Now you have these points. So what is the smallest here? Smallest will be given as rank 1. Okay, Nama? Smallest will be given as rank 1. What is the next smallest? 2.0, rank 2. But there are 2 lines, they have rank. So 3 and 4. 3.2 is 5. Is it okay for all of you, Ma? Now I will discuss what is K value. Everyone please note down. The K value can be taken from 1 to, everyone please note down, square root of number of rows, number of observations. So what is an observation? For example, if I take this data, how many observations are there? There are 18 observations are there. So the k value can be 1 to square root of 18. So it will be either 4 or 5. So k value lies between 1 to 4 or 5. Is it okay for all of you? And now I will wait for 1 minute, Amma. Any questions, Amma? In KNN algorithm, how to find out k value? K value will be taken from 1 to square root of observations. Observations are also called as records. The number of records in the database. Most of the students are considering columns. Okay, Nama? Not that. Now, what is my second step in KNN algorithm? Find the k nearest neighbors. For example, when I now, whenever I take k equal to 5, what is happening? See here. When I take k equal to 5, see here what is happening. Please observe. If you observe k equal to 5, now you can see here. You can take this point. See here. When k equal to 5, 80% of the records are showing medium t-shirt size and 20% of the records are showing large. Okay. So what I will assign for unknown variable 161, 61, I will assign the target variable as medium. Now, when I take k equal to 4, what will happen? When k equal to 4, all 4 records, see here, all 4 records shows the target variable as medium. This is the mathematics of KNN algorithm. Okay. Now, everyone is okay, Nama? I will wait for 1 minute. If you have any questions in this KNN algorithm mathematics, please ask me. I will be happy to respond to you. Please. Any questions, Amma? Please. Kindly respond to me. Now, with your permission, can I go for case studies? Can I go for case studies with KNN? Kindly respond. Yes, I think they are not responding. Please. They are not responding. Yes. I think they got the point. They got the topic. Yes. Now, yes. Yeah. Thank you, Amma. Please. Thank you very much. Now, I will increase the font. Can you please tell me? Now, first of all, I will implement this KNN algorithm on simple data set first. Okay. First of all, I will be taking a simple data set called as iris data set because this is the generalized data set. First of all, see here, I'm importing NumPy for mathematical operations, feed pandas for data analysis, and now in order to do pre-processing steps, I will be importing sklearn, not pre-processing. Okay, for all of you. Now I will be reading the data. Pandas object dot read underscore CSV. I will be reading data from a CSV file called iris.csv. It will be stored in a variable called as data1. Now, data1 is a data frame. Can you respond, Amma? Totally, we have 150 rows and 5 columns. Now, whatever the problem we are solving in the internship, in the coming Saturday, we will share you 3 problems. One from regression, one from classification, one from clustering. Out of the 3 problems, the students can choose at least 1 problem. So, kindly listen carefully and complete the assignment. Okay, then you will get certificate. Then, first of all, you have to study the data types. Now, the target variable is object variable and the remaining variables are input features. So, you need to go for encoding. Okay, now, then you have to go for checking whether do we have any null values or not. Now, if that, it will be checked by using a function called isNull.sum. There is no missing values. So there is no need to do imputation process. Then everyone listen carefully, Emma. Whenever you have to take any problem, okay, whenever you take any problem, first of all, you have to identify what are the input features. Okay. Then you have to identify what is the output feature. Okay, for all of you. After identification of input features X and output features Y, you have to identify how many class labels are there. Is it binary or is it multi-class or is it multi-label? To identify how many labels are there, we have a function called unique function. See here, data of class dot unique. This is the target variable. Now, unique function is saying that there are 3 class labels. One is Setosa, next one is versicolor, next one is Virginica. Now, ask how many target variables are there? How many are with Setosa? How many are with versicolor? And how many are with Virginica? For that, I will be calling a function called value underscore counts. Now I can easily say that total 150 records are there. 50 records with Setosa, 50 records are with versicolor, and 50 records are with Virginica. Is it okay for all of you, ma? Then you have to do one job, because see here, the target variable is a categorical data. You have to convert the categorical data into numerical data. See here, this can be done by using three techniques. In my data pre-processing, I told three techniques. First one is a pandas version. Second one is a label encoder. And third one is a one-hot encoding. One-hot encoding. Okay. Now I will be using sklearn.preprocessing a class called label encoder. Okay, Nama? Now, I will be creating an object of the class, then use a function called fit underscore transformation. So my class label will be converted from categorical data to numerical. See here, see here, see here. What happened? Earlier, my class labels are Setosa, versicolor, and Virginica. Now they have transformed to numerical data. This process is called as encoding. Kindly respond, Nama. Okay, Nama? Now, then I will be dividing the data into input X and output Y. This can be done by using, see here, data frame dot loc, all rows and first four columns will be X and last column will be Y. See here. Okay, Nama? See here. Sepal length, sepal width, petal length, petal width will be X. Now my target variable is Y. Okay. Now I have entered data in terms of numerical data. Then the third step of data pre-processing is converting the data into zeros and ones. Yes, it will be done by using either standard scalar or min-max scalar. Min-max scalar will convert the data into zeros and ones. Okay, Nama? That's it. Yes. Now, if you observe this data carefully, total data has been converted between zeros and ones. Is it okay? Later, I will be dividing the data into four parts. We already discussed yesterday itself. Okay, Nama? This is X train, this is Y train, this is X test, and this is Y test. Is it okay? Now, this can be done by using a function called train underscore test underscore spread. Okay. Now, let me implement. Yes, look at here. Yes, look at here. Now, our job is to use KNN classifier. Now, because I'm using scikit-learn library, okay, if I want to work with KNN classifier, I have to import from sklearn.neighbors. My class name is KNN classifier. Okay, for all of you, ma? Then I need to create an object of the class. Okay, once you create an object of the class, the first phase is called as training. Okay. Now, the training can be done by using a function called model.fit function. Here, I will be using by xtrain and ytrain. This phase is called as training the machine. The next phase is called as testing. How the testing will be done? Testing can be done by using algorithm name.predict, where I will be sending xtest as an argument. So I will be getting output called y prediction. This phase is called as testing. Now see here, I wanted to print y test values as well as predicted values. See here. Now what we have to do? Y prediction. I think somewhere run all cells. If I miss any cell, it is giving some mistake. Nothing will happen. See here. Yes. Now there is no error. See here. Now I yesterday showed that y test is a data. It is not given for training, not given for testing. So this data is called as original data or ground truth data. Ground truth data. Now I wanted to test original data with model predicted data. This can be done by using a function called accuracy score. Accuracy score is a function which will be imported from sklearn.metrics. Is it okay for all of you? I have y test is my original data. I am mapping with predicted data. So the algorithm has given 97.77 result. I hope it is okay for all of you. This is called as third step called evaluation. Now I will wait for 2 minutes. Any questions till now? Step by step I'm going. I applied imputation, I applied transformation, and I applied encoding. Then I have created an object of the class, then trained and tested. Is it okay for all of you? We will be happy to respond to you if you have any questions. Then I will be checking another very, very important, whether the model is correct or not. It can be tested by using a beautiful technique called confusion matrix. Okay, here, confusion matrix is a pictorial representation or graphical user interface of checking the model is correct or not. See here, when this diagonal is having high values, see here, 12, 12, 20. Yes, when these diagonal values are higher and other values are less, then I can say that my model is good model. Okay, for all of you till now, please kindly respond. Please kindly respond to me. Please kindly respond. Yeah, any questions till now? That's it. Now, I wanted to discuss another very, very important concept. Please, everyone listen carefully. Next 5 minutes, I want everyone listen carefully and ask the doubts. Now, what is my topic is, I wanted to ask 2 questions. Okay. My first question is, see here, 70% of training data and this is 30% of training data. Okay. Now this is called as X train, this is called as Y train, and this is called as X test, and this is called as Y test. Now, my first question is, am I using 100% of the data training and testing? Can you respond to me? Please. Am I using 100% of the data for especially training and for especially training testing? Answer me. Dear students, can you please answer me? Second question is, now, whatever the results which are coming, are they stable? Are they stable? No. Answer is no for all of them. See, 70% of the data only I'm using for training and 30% of the data only I'm using for testing. So the answer is no for this question. And my second question is, are the results are stable? My answer is absolutely no. If I run the same algorithm in my machine, I am getting 97.77. Mostly, if you run the same algorithm on your machine, you may get 97.27, maybe. So whatever the results which are given by one algorithm are not same as other algorithm. So with your permission, I want to discuss another technique called cross-fold validation. Can I continue? Now, in order to solve these 2 problems, I wanted to discuss about another technique called cross-fold validation. So with your permission, can I take a pen? Look at here, please. Please, everyone note down cross-validation. Cross-validation. In short, in industry, that is called a CV. CV means it's not resume. Cross-validation. Okay. Now, what is cross-fold validation? Here, data will be divided into here. CV can be 5-fold or it can be 10-fold. It depends upon the availability of the data. See here, the data D will be divided into 5. If I take 5-fold validation, my data will be divided into 5 parts. 1, 2, 3, 4, and 5. Okay, Nama? I will be dividing my data into 5 parts. This is part 1. This is random sampling. This is part 2. This is part 3. And this is part 4. And this is part 5. Okay, for all of you? Please kindly respond to me. I have divided my data into 5 parts. Now, 20%, 40%, 60%, 80%, and 100%. So, what is the meaning of cross-fold validation? We have divided the data D into 5 parts. Then, here, 2 minutes. Give me 2 minutes. Now, first 20% will be given for testing and remaining 80% will be given for training. Then I will be getting accuracy 1. In the second iteration, 20% will be given for testing and remaining data will be taken for training. I will be getting accuracy 2. Okay. Now, in the third iteration, this data will be given for testing and this part and this part will be given for training. And I will get accuracy 3. In fourth iteration, this data will be given for testing and remaining data will be given for training. So I will be getting accuracy 4. Finally, this data will be given for testing and remaining data will be given for. Now I will be getting accuracy 5. Now I wanted to calculate, see here, average of the data. Average of data. Now, once again, I'm asking the same two questions. Please, kindly respond to me. Am I taking 100% of the data for training and testing? Now respond to me, Amma. Now respond to me, please. No one is responding. It is not the good way to learn the subject. Kindly respond. Yes, we are taking 100% of the data for testing, 100% of the data for training. And my second question is, all the results are stable? All the results are stable. Absolutely, yes. Results are stable. Arshu, why it is no? Yes, the results are stable because I am not taking one algorithm result. I am taking 5 results and I am doing average of the data. No, we are using 100%, Amma. We are using 100% of the data for training, 100% of the data for testing. So, first question is yes, and second question is yes. Now, shall I implement this concept? Whatever I have discussed till now, I will be implementing. Now, some students can ask one question, Amma. Sir, why you have taken 5-fold? Why not 10-fold? Okay, this cross-validation 5-fold and 10-fold depends upon availability of the data. Okay, when the data set size is large, I will take CV5. When the data set size is small, we will be taking CV10. Okay, for all of you, Amma? Now, shall I implement this concept through programming? Can I erase it, Amma? Yes. Now look at here. All of you. Can you look at here? Now, here. Now, what is the K value? K value can be 1 to square root of 150. Now, because I have 150 rows of the data, my K value can be ranging from 1 to 150. Now, sir, only taken one row. No, I'm not taking one row. I have taken 5 rows of the data. I have taken CV equal to 5 kada. Okay, Nama? I have taken CV equal to 5. Now, square root of 150 is either 12 or 13 kada. So, A value will be ranging from 1 to 12 or 13. Now, see here, I will be taking a list comprehension where I in range of 1, 13. So, initially, I will be getting 1. Here, I will be taking 1. Now, I will be doing standard scalar of the data. And initially, K value is 1. Then I'm creating a new algorithm. And I'm calling cross-validation score. Kindly look at here. Cross-validation score function consisting of the first argument is algorithm. Okay. And second argument is input X. Third argument is output Y. And fourth argument is how much CV you are using. Here, I will be using cross-validation 10 here in this. Now, for every K value, I'll get one score. This scores I'm appending onto the list object called scores. Now, see here, everyone. Because my cross-validation is 10, I will be getting 10 results. See here, I will be getting 10 results. Okay. Now, I will be drawing a line plot. Now, if you observe this line plot, on the x-axis, I have taken K value. X-axis has been taken for K value. And y-axis has been taken accuracy of algorithms. Now, if you observe carefully, how can I interpret this? Here, how can I interpret? When K value is 11, I am going to get good results. See here, when K value equal to 11, I will be getting good results. Okay. So what I have to do? Now I need to consider K value equal to 11. Then I will prepare a new algorithm, new model. Now everyone understood this interpretation, Amma? Please. Everyone understood this interpretation? Now what I have to do? See here. There is a function called argmax. Now see here. Argmax is a function 0 to 10. So when K equal to 11, I will be getting good results. See, now I will be taking Next value, I created algorithm. Here, my K value 11. Then I am going to calculate the accuracy. Here, I got 100% results. Earlier, I have only 97.55. Now, if I take best K value, the results has been gone to 100%. Okay, for all of you, ma? This is what is called as the basic introduction to KNN algorithm. Okay, for all of you? Please kindly respond to me. I will be happy if you ask any questions in KNN till now. So, if you have no questions, shall I shift my focus from KNN algorithm to next algorithm called as Bayes algorithm? Okay? Respond, Nama. Now, I will be shifting my focus from KNN algorithm to yes, Bayes algorithm, because the time is very constrained. I am unable to teach mathematics of Navy-based and decision tree algorithms, Sama. I have given mathematics only for KNN. Okay, Nama? Please. Now, I will be going to discuss about case studies. Yes. Now, look at here. Now, first of all, I will show you the database. Which database I'm taking? Implementing the case study. Yes, look at here. Now, in Bayesian algorithm, I have taken a cancer database. I'm taking all healthcare data sets, Sama, please. I'm taking all healthcare data sets. Now, if you observe this data set carefully, you people are going to find 32 columns officially. See, there are 32 columns are available in the database. Okay. Now, out of this column, diagnosis is very, very important. Now, here, M stands for malignant, and there is another cancer database called benign. Here, B stands for benign, where B is a non-cancerous and M is a cancerous. So, with your permission, can I take this case study and implement, Amma? Respond to me. Now, I will be taking this end-to-end case study. I will take. Please respond to me. Yes. Can you please look at here? Import NumPy, pandas, and the data pre-processing. Then let us read the data. My cancer data set. See here. How many data records are there? There are 569 rows with the 32 columns. Okay. Out of 32 columns, see here, ID is not at all required. With ID, no one will get cancer. But diagnosis is my target variable. Okay. So it is a binary classification because I have two class labels, malignant and benign. Clear for all of you? Now I am dropping the IDC here. I am dropping ID column. After dropping ID column, I have only 31 columns. Can you respond, Amma? Now, what I am doing? I am taking diagnosis is my target variable. See here, diagnosis is my target variable. Now what to do? You have to convert M into M and B into zeros and ones. See here, yes, we have converted the diagnosis M and B into numerical data. This stage is called as encoding. Now see here, value underscore count. See here, out of 570 records, no cancer is 357. Cancer records are 212. Okay, for all of you. Same thing can also be done like this. See here. Now, you have to know what are the class labels are there. First class label is 1 and second class label is 0. Is it okay for all of you, ma? Now, up to here, okay. Then I have to divide input data X and output data Y. How it will be dividing? See here. My first call X. See here. What is X? LOC of column 1 to 31. 0th column is target variable. So I will be dividing the data into X and Y. See here. Here, everyone. Now, here, except target variable, all the data has been gone to Y. Okay, Nama? Now, see here, what I am doing, I am converting my data into standard scalar. Okay. Then I am dividing my data into 4 parts. Okay. Now, let us discuss about Bayesian algorithm. Okay. Officially, there are 3 different kinds of Bayesian algorithm. Okay. Now, one among them I'm using is called as a Gaussian Navy-based algorithm. Okay. One thing. Now, when can I apply Gaussian Navy-based algorithm? When the data is following normal curve. Okay. When the data is following normal curve, we can use Gauss navigation algorithm. Okay. Now see here, this is mu and this is minus 3 sigma and this is plus 3 sigma. Okay, for all of you. Now, first of all, I'm importing the library, creation of an object and train the data. See here, then predict it. Now let me run one by one. Now see here, these are my predicted data and these are my test data. Now I'm going to calculate accuracy. See here, I got 94.12. Now I hope everyone understood the structure, how to do classification. But now in the next case study, I will be going end-to-end implementation of a new project. So with your permission, from these two case studies, you know how to train the data and how to test the data and finding the evaluation metrics like accuracy and confusion matrix. So with your permission, I will wait here for 2 minutes. Then I wanted to go for one end-to-end case study. Okay, for all of you. Can I continue, Amma? Please kindly respond. Any questions as of now? Now, I want to show you the data set. Now, I would like to listen from you. Now, whatever the data set I'm taking, this is the one of the most important data set, Amma. Most important data. And students will have high learning curve with this data set. Please. Please. Why I am saying that students will have high learning curve? Because, see here. Now, whenever you take any database, please, whenever you take any database or set, more here, you will be having numerical features and you will be having categorical features. Okay. Here in this data set, 50% of the data is numerical data and 50% of the data is categorical data. In that categorical data, 50% of the data is ordinal and 50% of the data is nominal. Now, can anyone tell me what is the difference between ordinal data and nominal data? This is the perfect case study. If you learn this case study, you can do your internship project very easily. So with your permission, can I go slowly one by one, Amma? Can I go slowly one by one? Okay, Nama? Now, so we'll be going to the data set. See, everyone study the data set, Amma, first of all. First feature is age feature. Age feature. It is a nominal data. See here. Sorry, it is a nominal data. See here. Then most of the features are nominal data and ordinal data. I'll take a small case study end to end. Now I want everyone please listen. And the target variable is class. Recurrent event and no recurrent event. It is a binary classification. So with your permission, can I go end to end? It is a little bit complex also. So I want everyone, please listen carefully. Okay. If you understand this case study, you can do most of the projects from Kaggle. You can handle with single hand. Okay, please. So with your permission, can I go, Ma? It is fascinating. Okay. Okay. Now, first of all, let us import it. Then let us read the data. See here. Let us read the data. My data set consisting of 286 rows and 10 columns. Okay, for all of you. The first stage is, please, everyone, first step is load the data. Okay. Then the second step is check out how many missing values are there. Then this process is called as imputation. Here, imputation can be checked by using data frame dot is na.sum or is null.sum. Both are same. Okay. Now let us check. Do we have any missing values? E. No missing values. But in the next case study, we'll deal with missing values. Now here, I will be taken two things. See here. Now, what is the meaning of ordinal data and nominal data? Please, Amma, very, very important. Categorical data once again divided into categorical data once again classified into ordinal data and nominal data. Okay. Can anyone respond? What is the difference between ordinal data and nominal data? No one is responding. I already discussed about in my first class. What is the difference between ordinal data and nominal data? Okay. Now, in this case study, I will be taking as manual. Yes. Okay. I'll discuss otherwise. Ordinal data means we have to follow some order. Follow some order. Okay. Or we will follow the data in a specific scale. Maybe 0 to 100 or maybe 0.0 to 10.0. Okay. Now, nominal data means here we don't follow any order. No order of the data. No order for data. Okay, Nama? Because this funda is mandatory for everyone, Nama. Now, I will be taking age feature, tumor size feature, these features as ordinal data. Now, here, I will be asking how many class labels are there for every individual features. For that purpose, I have running the loop for variables in ordinal data dot column. So, first of all, I will take yes, and I will be calculating unique. See here what will happen. Now, unique, see here, age has so many class labels. See here. Then, tumor size is also having so many types. It is called as ordinal data. Okay, Nama? Can you respond to me? Instead of taking unique function for every attribute, we have taken using for loop. Now, I know that these are the class labels for ordinal data. Okay, for all of you? Then I will be taking another data called nominal data. See here. Here we are not following any order. For all of you. Now, I will be doing automation process. This is very, very important, please. The first step is called as data pre-processing. Entire data pre-processing has been done here. First of all, I have taken target variable. What is my target variable in the data set? Recurrences and no recurrences. So, first of all, I'm converting the data into numerical. See here, I have converted. The target variable has been converted into ones and zeros. It can be done by using label encoder. Okay. Now, the next step is difficult one, please. See here, all the rows except ninth column will be taken into X. See here. See here, most of the data is categorical. And last column is target variable. Now, let us divide the data into 4 parts. Now, let us start. 10 minutes Sunday. It is very, very important logic. Now, I will be using various automation techniques. First one is one-hot encoder. Okay, this class is responsible for converting categorical data to numerical data. Okay, na? Then simple imputer. This is for using imputation purpose. Okay, and ordinal encoder. To convert ordinal data into numerical data, we will use it. And I will be using another class called column transformer because I wanted to transfer all the columns into data. Then another technique what we are using is called as a pipeline. So what is the meaning of pipeline? In machine learning, the meaning of pipeline is putting all the data in the form of list of tuples and execute at once. This pipelining process is used for automation of machine learning process. With your permission, can I go one by one? I have given beautiful notes also, Nama, here. Here, I have given entire beautiful notes for your understanding purpose. I will share to you, okay? Now, can I continue, Amma? Now, first of all, I have taken ordinal features into one variable and nominal features into another variable. Okay, Nama? Now, see here what I'm doing. I will be creating a transformer. I will discuss one by one. Nama. Always, the transformers has to be taken in the form of list of tuples. Okay. Now, it consisting of 3 variables. See here, will be showcasing one by one. Nama. See here. I will be discussing about 3 variables. These are the 3 variables. See here. First one is the name. Second one is the class. And third one is which column we are applying. See here. Now, here, The first one is name of the transformer is nominal. And second one is which class I'm using, one hot encoder. And third one is on which attribute I'm applying. I'm applying this class on this nominal features. Is it okay for all of you? Then another one is ordinal is the name, and the class is called as ordinal encoder. This encoder I'm applying for ordinal features. Okay, for all of you, ma? Now I will discuss about pass through in 2 minutes. Okay, for all of you. Now I wanted to transform these two columns. For that, I will be using another class called column transformer. My job is done. Once I am converting both ordinal data as well as nominal data into numerical data. Here, this can be done by using a technique called preprocessor. See here, now, entire preprocessor will be done, and I'm using imputation process. Now, imputation process I'm doing separately. Now, numerical data here for simple imputer can be used for two purposes. Okay, here most frequent data I'm using for pre-processing techniques. Can you respond, Amma? Yes, just give me 1 minute. Let me run all the cells. Let me run all the cells. Now, look at here. Entire data has been changed to numerical data. There is no missing values. See here. Entire data has been changed to numerical data. Okay, for all of you, Amma? See here. The biggest challenge is how to convert ordinal data and nominal data into numerical. See here, I have discussed a beautiful information also for you. Okay, see here, column transformer. This is the main class that apply for different transform. Now, two transformers we are taking. First one is ordinal. The next one is one hot encoder. Okay, it takes list of tuples as input. I told you I need to take list of tuples as input where each tuple specifies the column name to be applied. Okay, for all of you, Amma? Here, every step I am discussing, Amma. First one, transformer. Then the next technique, what I have replaced called as transform. See here. Now there are two transformers we are using. One is a one hot encoder and one is a ordinal encoder. These two we have taken in the form of list of tuples. Now, I told you, I will discuss about pass-through. What is the meaning of pass-through? See here, Amma? Beautiful information I have given here. The meaning of pass-through is sometimes we cannot convert the columns. Sometimes we cannot convert the columns from categorical to numerical. Let us keep them as it is. For that purpose, we will use pass-through. Okay, for all of you, Amma? Is it okay for all of you? Then I will be using pipeline for training data as well as testing data. Okay, for all of you? And then look at here. Now, very, very important job I'm using. Selecting the best features. Selecting the best features. So, I will be calling a function called select underscore feature. This is a function which is written by us. Select the important features from the database. Okay, for all of you, ma? Selecting the best features. It is the function which is written by us to select the best features in the database. So, the first argument is called as normalized data, and second one is called as training data, and third one is test data. Now, whenever I call this function, I will be calling a function called select k best. Yesterday I discussed about it. Select k best. Now, it will take the first argument as chi-square, and second argument is all features I am taking. Then go for fit function and transform both training data as well as test data. You people are getting three values. See here, the three values will be placed here. Now look at here. Now I am saying three best features. See here, what are the best features are there? See here, I will be showing to you in 2 minutes. See here. Now let us print what are the best features are there. See here. See here. Feature 0, 0.29, feature 1, 0.35, and see, let us draw the bar graph. See here, feature number 13 is very, very important. Clear for all of you, ma? Then go for take Bayesian algorithm, fit function, and training. I hope it is clear for all of you, ma? This is the end-to-end case study that will be useful for you in the internships. Is it okay for all of you, ma? Now, if you ask any questions, I will be happy to respond for your questions. Okay, Nama? Okay. Now, end-to-end case study. Now, whenever you are doing internship projects, kindly listen the video for 2 to 3 times. Okay, for all of you, ma? Now, with your permission, can I take one more case study using decision tree algorithm? Can I introduce decision tree algorithm? Okay. Yeah. Now, I will be discussing about, first of all, I'll discuss simple case study from decision trees. Okay, Nama? Here. First of all, I will take a simple case study. Okay. Now, I will show you the database in 2 minutes. See here, how many records I have. See here, very simple case study for the people who wants to explore by themselves. Simple case study I have taken, Amma. Please. In this case study, I have taken 3 input variables. First one is a company where the employees are working. Maybe it has Google, ABC, X Pharma, and Facebook. Another column is job. Are you working as sales executive or business manager or computer programmer? Yes, I'll increase the size, Amma. Now, okay? Arshu? Now, okay, Amma? And third column is degree. And my target variable is whether the employee having more than 100K salary or less than 100K salary. So 0 stands for less than 100,000 salary. 1 means greater than 100,000 salary. So shall I take it as binary classification? Shall I take it as binary classification, Amma? So can anyone suggest how to start with this problem? Here, first 3 columns are categorical data. So you have to do encoding techniques. See here. Now I will be dividing the data into input and output data, except salary, everything will be input data. See here. Very simple case study I have taken for your understanding purpose. Okay, now please respond, Amma. Kindly respond. Now, what I am doing here, this is my target variable. Okay. Now I will be going to discuss about, see here, I will be discussing about label encoder. Now, 3 columns. First one is company, next one is job, next one is degree. I'm converting into label encoder. Then see here, fit underscore transformation. Now look at my inputs. See here, my inputs are, yes, I have converted all my categorical data into numerical data. See here, company, job, degree. Now, shall I drop this company, job, and degree? We'll drop it. See here, inputs dot drop. Then this is my final output. See here, my entire data has been converted into numerical data. Okay, for all of you, ma? Now, let us take a decision tree classifier. Okay. First of all, create an object of decision tree classifier. Then go for fit function and go for score. See here? Yes. 100% results I am getting. Now, I am taking 2 unknown data. See here. When a person who is working in Google and he is a computer engineer and is having bachelor degree. So I'm giving this input. See here, output is 0. 0 means he will be getting less than 100K salary. Now I will be taking another input. Google computer engineer having master degree. See here, 211, and its prediction is 1. Okay, a person who is working in Google as a computer engineer, master degree, he will be more than 100K salary. Is it okay for all of you, Amma? Okay. Now I have given 4 case studies, simple to complex. So with your permission, can I take one more case study? A little bit complex one, please. Can you respond? Is it okay for all of you? Yeah. Now let me go to another very, very important and most crucial and complex case study. This is called as a adult income data set. This is the beautiful case study to learn. Okay. First of all, I'll show you the database, Amma, please. Adult income. This is also one of the beautiful data set, Amma. Please see here. Why? Because see here. Once if you look at this database, you will be found why I have taken this data set. See here, are you finding any observations from the data set? Look at here. Are you finding any observations from this data set? Okay. Whenever you observe the data set, see, I'll take one point. Most of the cases you are finding blank. Okay. Most of the cases you are going to find blank. Blanks will be referred as NaN. Then I will go for imputation step. But in this case study, I don't have blank. But instead of blank, I will be having question mark. How to deal with question marks? This is the one of the best case study. See here, most of the data you have question marks. So how to deal with question mark? I will tell you a shortcut. I will tell you a shortcut. See here. My shortcut is, let us import the data. See here. Let us import the data. Take first 5 records. Now, two people are finding question marks. If you have blank data, you will be getting NaN. But how to deal with question marks? This is $1 million question. Now, one simple thing I will tell you, Amma. See here, what I am doing? Simple manipulation I am doing. Data.read_CSV, and wherever Na is there, I'm replacing with missing values. That's it. Now, every question mark will be replaced with NaN. That's it. That's it. Now, I can overcome this question mark problem with this. Now, I can go for each null.sum. This is the one of the typical problem most of the students are facing. So, I made it very simple. Is it okay for all of you? Now, once if I convert the data into NaNs, then it is easy process. See here. Then it is very easy process to count the data. See here. Work class having 1836 blanks. Occupation having and native country having blanks. So in my last classes, I had not imputed categorical data. Now I'm imputing categorical data. See here. Now in my last class, I told one rule that to impute categorical data, what to do. Tell me, to impute categorical data, I told one rule. That rule is called as mode. Is it okay? I have to use mode operation. See here. See here. I am calculating for that entire column, I'm calculating mode of the data. Then after imputing this value, now I don't have any missing values. I hope it is clear for all of you, ma? See here. If you have any question in this, I will be happy to respond to you, Amma. Please. Please kindly respond. See here. I am calculating mode of the data. See here. If I calculate mode of the data for work class, it is given private. So wherever missing values are there, it is replacing with private. In place equal to true means it is commit function of the database. Okay. In place equal to true means it is just commit function of the database. Okay, for all of you. Then the remaining thing is same. Here. Now, another very, very important task everyone should know. How to identify, please here. How to identify. This is very, very important topic. How to identify object data and numerical data. This is the point of question. Now, here data frame dot select underscore d types. Select underscore d types is a function. Here I am asking to search object data. Say here, all this data is a categorical data. Okay. Now here I am asking select underscore exclude object data. And I will be getting numerical data. See here, I will wait for 1 minute. I will wait for 1 minute. Now, if you understand this too, see here, this is nothing but numerical data. This is nothing but categorical data. Okay, for all of you, ma? Any questions till now? Now, what I am doing, I am taking all categorical data and using label encoder. Within a single line, I will do everything. Okay, for all of you, then another technique I am using for converting the data from target variable to categorical data. That can be done not only by using label encoder, I can also use map function. Here, when the salary is less than 50K, 0, greater than 50K, 1. Okay, for all of you, ma? Okay, for all of you, this is also another kind of encoding technique. Okay, for all of you, the remaining things are same, ma. Same to same. Divide the data into X and Y. divide the data into 4 parts, then create an object of decision tree classifier, then fit function, then predict function, then accuracy score. Now let me run all of them. Yes, my job is done. Clear, Amma? Now, here in this case study, I have discussed a new kind of things, how to deal with question marks, okay, and how to select numerical data and how to select categorical data. If you practice these 5 case studies, you can start any kind of classification technique. I hope it is clear for all of you, Amma. Now, I will wait for a few minutes, okay? Now I have given a beautiful 5 case studies for your discussion in this since 1 hour 5 minutes. Okay, for all of you. Now I'm waiting for questions, Sama. If you have any questions, I will be happy to respond to you. Yes. So now, if you permit me, few minutes I will discuss about metrics for classification. Very, very important concept. That will be the end of the topic, please. See here, you people are finding accuracy and confusion matrix. How to check the validity of that? See here, I will discussing for few minutes. What is the metrics for classification? Okay, for all of you. Now, my next case study is, see here. I want everyone listen carefully. Last one is now whatever the projects you are using in classification. In last class, in regression analysis, I have discussed about RMSE. Here, in my last class, I have discussed about 2 techniques, RMSE and R square. These 2 are metrics for regression. Okay. These 2 then what are the metrics for classification? What are the metrics for classification? First one is accuracy. Then second one is confusion matrix. Okay. Third one is precision. Fourth one is recall. Fifth one is F measure. Next one is very, very important, ROC, receiver operating characteristic. Next one is AUC, area under curve. These are called as various metrics for classification. Okay. After completion of your project, you have to check all these things to get the validity of your model. So with your permission, next few minutes, can I take this? Yeah. Now, I will be teaching end-to-end case study, Amma. Everything which is necessary for internship, I will be teaching. Okay? Yes. Now, you respond to me. Let me clear the screen. Yes. Now, I will be taking the cancer data set. I completed it. I'm going directly cancer data set. Now, let us see here, Amma. Everyone, see here. My first metric is called as accuracy. See here. My first metric is called as accuracy score. Now, I will be sending Y test value and Y predicted values. Okay. My Y test values and Y predicted, I will be getting accuracy score. First of all, let me run all. Then I'll show you the output one by one. See here, Amma. See here. My accuracy is, how can I calculate accuracy? I need to send original data and predicted data. See, it is giving 91.22. Okay. Then how to calculate precision score, precision underscore score. Same data. Y test value and Y predicted, it is given 87.17. And recall value, 87. See, confusion matrix. This is too positive and this is too negative. So 70 and 34, this diagonal is higher. So this model is good model. Okay, for all of you, see here. By looking at this confusion matrix, I can easily say that the model is good model. See here. After that, I should go for another metric called ROC. See here, ROC stands for receiver operating characteristic, where your value must be above 50%. Here you have 90.3. Yes, your model is good. Finally, another metric called AUC. See here. Now 90, all the metrics are giving answers as above 90%. So can I say that my model is good model or not? Please tell me, Amma. Every machine learning algorithm you have to end the case study with these metrics: accuracy, precision, recall, confusion matrix, ROC, and AUC. This is the end of my session. Now, if you have any questions, I will be happy to respond to you, Amma. Please. Kindly respond, Amma. Any questions? Any questions? And today, I have given end to end. Okay. I have given end to end. Okay. So, I hope by taking this knowledge, you will start on Saturday. We will be sharing 3 case studies. Okay. Yeah. Thanks to one and all for joining. Thanks very much.